with this lesson. So in the last time, in the last class, we were doing the all right. We were doing this portion last time, and we had started the Nernst equation. As I told you yesterday, that this topic was included in the A levels in 2016. So before this year, you wouldn't find the questions of Nernst equation in this in the past. So after that, we studied the formula of the Nernst equation, in which we make use of this formula to find out the electrode potential value of the reactions. Later on, we were familiarized with these variables which are used here: R, T, Z, F, and all of these values, all of these variables. Then at the end, you will use this last formula for your calculations. You have to use this one. E is equal to E naught plus 0.059 over Z into log of oxidized species divided by reduced species. And within that reaction, the oxidized species are the one which are which have, in a sense, which have higher oxidation number. For example, if it is the uh, conversion from iron 2 plus ion into iron 3 plus ion, then the one which has higher oxidation number will be the oxidized species, and one which has a lower oxidation number is a reduced species. Okay, then we now solve one other question to check the uh, numerical answer of the question. Okay, here's the question. Question number 8. The question number 8 says, calculate the value of the electrode potential at 298 Kelvin of a copper into copper ion. Okay, wait, before that, we have to go through this portion. Note that if the temperature is not 25 degrees centigrade, the full form of the Nernst equation must be used. If both the oxidized and reduced species in solution have the same concentration, then this ratio is 1. And since log of 1 is equal to 0, it means that electrode potential value at non-standard condition will be equal to the electrode potential value at the standard condition. Note that this applies to any concentration. For example, even if we have the 0.05 mole per dm cube oxidized species and 0.5 mole dm cube of the reduced species, which means if both the concentrations of two different ions are same in the chemical reaction, then as a result of this, you will have this value. Why is it? Why will you get E equal to E naught? Because in that case, the fraction of oxidized species divided by reduced species will become same. The value will be same. Over here, they are taking the value 0.05 divided by 0.05. So they will be cancelled. You will get 1, and the log of 1 is equal to 0. So this whole expression will become, yes, this whole expression becomes 0, which means we'll be left with only this expression, E is equal to E naught. Now here is a numerical question. Calculate the value of the electrode potential at 298 Kelvin of a copper into copper ion aqueous electrode that has a concentration of copper ion aqueous of 0.001 mole per dm cube. and the value of the electrode potential is given, that is plus 0.34 volt. The same value is mentioned in the electrochemical series. So we have to find the value of the electrode potential at 298 Kelvin of our copper ions, considering that the concentration is different. It is not a standard condition. Adila, what's the standard condition in terms of concentration?
Yes.
What's the standard condition of concentration in the electrolysis?
I'm not sure.
We discussed this yesterday as well.
I
1 mole per
forgot.
dm cube.
Okay.
1 mole per dm cube. So here the concentration value is different, which means we are supposed to find the E value
Yes.
using the Nernst equation. Okay,
Okay.
we have this formula E is equal to E naught plus 0.059 over Z into log of oxidized species divided by the reduced species. I'm going to write the full formula here because I need to explain this formula. 0.059 over Z into log of oxidized concentration of oxidized species divided by concentration reduced species. What's the meaning of this K brackets, Adila?
What?
These K brackets, what's its
Yes.
meaning?
They're getting multiplied.
These square brackets.
Yes. They're brackets.
Yes, yes. Concentration in terms of which unit? Mole per dm cube. Yes. Adila, it's
Yes.
the square brackets means concentration in mole per dm cube, which you have studied in
Okay.
the AS.
Yes.
It doesn't mean multiplication because I'm
Oh.
not using any multiplication sign here.
Okay. My bad.
No problem. So square bracket indicates the concentrations, but in terms of mole per dm cube, although we do know that there is other unit as well for the concentration. What other unit do we use for concentration? Adila, you?
Yes.
Can you tell me any other unit for the concentration?
Kilomoles? No, kilojoules.
That's the unit of energy.
Oh, okay.
It's gram per dm cube.
Okay.
Gram per dm cube. Adila, we will inshallah try to get some more gadgets of advanced type in which you
Yes.
will be able to hear the sounds of the student sitting in front of me so that you
Okay.
can
No,
have
I'll be coming to
cross.
the academy as well.
Yeah,
I'll be
sorry.
coming. I'll be coming to the
Okay,
academy. Yes.
okay, but we will facilitating the online students as well in terms of this cross questioning so that
Yes.
you can hear what kind of question the other students are asking in the physically presence. Okay.
Okay.
Now the question says that we have the concentration of copper ions, which is 0.001 mole per dm cube. Now we have to construct the chemical equation for this reaction, copper to copper ions. How would you represent this equation? We will write. We have to write this in the form of the electrochemical series or the reduction reaction. So copper plus 2 gaining 2 electrons. Copper is in the aqueous form and it will convert into the copper solid, right? And the arrow is reversible arrow. That's how we represent the reduction reaction for the copper ion. Now the value given here belongs to which species? 0.0001. Yes, Adila.
Yes.
To which value is this species belonging? Like, to which species does have this value 0.001? The copper
Cu.
or the copper ion?
Copper. Copper ion.
Copper iron. Yes, it's copper iron. So we
Yes.
have the value of this 0.001. Whereas this copper in the solid form is basically a solid, and we do not describe concentration of the solids. We do not describe any concentration value for these solids. Only for the ionic form of the metal will be described in terms of its concentration because it has been dissolved in the water. So we will reduce this formula into this type in which there is only the concentration of the oxidized species. As you can see, this is the oxidized species and the other one is the reduced species. For we can describe this on the basis of the oxidation number. Cu has zero oxidation state and it is a reduced form. Cu2 plus is the oxidized form. So no value is given for the Cu with the you can say the Cu atom. So this denominator variable will be removed. We'll be only left with the numerator value. We are now putting those values here in this expression. We get 0.001 for the oxidized species. And how much value we would assign to this Z? What's the value of Z and Y from this expression? This Z indicates what? You haven't been watching the recorded lectures and not revising the notes here. We saw that this Z stand for the number of electrons in the reaction. Now come back to this reaction. How many electrons are involved in this reaction, Nadila?
Yes.
How many electrons are involved in this reaction?
2 electrons.
2 electrons, which means the value of Z will become 2.
Okay.
So we put the value of 2 here. Now we have substituted all the values except that the value of E naught is left, which is given already in the statement. So E naught value is given in the statement. Z is calculated from this reaction, and the concentration of oxidized species is used, not the reduced species, because the reduced form is the solid form, which has no concentration. Now, after substituting all the values, you simply have to use a calculator to find the value. So, if you have the scientific calculator with you, you can find this log of 0.001. That will be multiplied with the value of 0.059 divided by 2. So, log of 0.001, it gives me -3. The answer of this 0.001 is -3. Now, this -3 must be multiplied with 0.059 divided by 2. The value of this is 0.0295 into -3 gives me minus 0.0885. So 0.34 minus 0.0885 is 0. Plus 0.2515 volt. That's the answer from the calculator. So that's how we find the electrode potential value of this non-standard condition. I hope it's clear to both of you. Is it clear? Okay. There is some problem with this particular page. Another work example here. A silver electrode dips into a saturated solution of silver bromide, which has a solubility of 7.1 into 10⁻⁷ mole per dm³. What is E for this half cell? So it says that we have this chemical reaction in which the silver ion is being reduced to become silver atom and the electrode potential value is given. We have to find the E value for this half cell. Now again, we already know the formula to calculate the E value. So E value becomes E naught plus 0.059 over Z into log of oxidized species divided by reduced species. Now which of these two is the oxidized and the reduced species? Share first you, give me the answer, then Adila you. Which silver, left or right? My question is that this oxidized species represent which of these two, Ag or Ag plus? Okay, Adila, what's your answer?
I'm still doing it right now.
I'm asking this oxidized species, which is given in the formula, which species is represented in this reaction?
AG.
Recall your knowledge of the AS, the one which possess higher oxidation number. The higher positive oxidation number is the oxidized form. Isn't so?
Yes.
So which of these two has higher, more positive value?
Silver.
Both are silver. Ag silver, Ag plus is also silver. Which silver you are talking about? Left or right?
The left one.
Yes, the left one. The left one has higher positive charge. Okay.
Yes.
Ag plus is a oxidized form. We have to differentiate between the oxidized and the reduced. The one which has more positive charge on it will be the oxidized form. And the other one, the reduced species, will be the one which has less positive charge as compared to the other species. So in this reaction, Ag, what's the oxidation number on Ag? Adila, what's
1.
the oxidation? Sorry,
1.
on the left or right?
Left.
I'm asking for the right.
Oh, it's 0.
Yes, it's 0. So 0 is less positive than the plus 1, which means this is the reduced form. And
Yes.
Ag plus is the oxidized form. So after identifying the right species from the chemical reaction, you can now use the values from the given statement. It says that the silver electrode dips into a saturated solution of silver bromide, which has a solubility of 7.1 into 10 raised by minus 7 mole per dm cube. Now this is the value of concentration, but whose value is it? That's the value of silver bromide. And what's the formula of silver bromide? It's AgBr. That's fine. It's AgBr. So the concentration value belongs to this hole, but within this compound, we know that Ag is present in the form of Ag plus, right? So this concentration is basically belonging to the concentration of the Ag plus. Now we have identified the Ag plus in this reaction as well. It is the oxidized form. So which means this value is showing the value of the oxidized species. So we have to substitute this value in the numerator. Which value will I use in the denominator? The Ag is in the solid form, and we do not, it has no value. So we do not take it 0, we take it as 1. So 1 value is assigned to the Ag solid. So that's given here. And the value for the electrode potential is already given. The standard electrode potential is given. E naught stands for standard electrode potential. So the value is given. We now substitute this value as well in the expression. Now after having substituted all the values, we get this answer. Then you are basically finding the log of the oxidized species. So after doing all the calculation, the answer will be plus 0.44 volt. Is it clear?
Yes.
Okay, now let's take another example. We can, this is from another resource book. We can think of the reduced species as a product and the oxidized species as a reactant. So this line is also highlighting the same thing which we have used in the previous calculation. We can say that the reduced species, this one, this is the reduced species, right one. The reduced species is basically the product, and the oxidized species is basically the reactant. In other words, you can also write, you can also amend this formula in terms of, in the numerator, you can say the reactant concentration divided by the product concentration, because product is a reduced form and oxidized is a reactant. But more valid expression is this one, oxidized species divided by reduced species. But in some cases, if you do not get the oxidation numbers, you can also use that formula. Okay, now this formula, this question, calculate the electrode potential in half cell containing the concentration of 0.5 mole per dm cube iron ions and 2 mole per dm cube iron 2 ions. So what do we have to do here? We have to consider that reaction in which both of these ions must be present, the iron 3 ions and iron 2 ions. So this is the reaction of that. This reaction is taken from the electrochemical series. In the electrochemical series, There's a reduction reaction. Now take the values from the statement. It says that the value of the 0.4 mole per dm cube is associated with the iron 3 ions, and 2 mole per dm cube is associated with iron 2 ions. So iron 2 ions and iron 3 ions. So I can write here 2 for this iron 2 and 0.5 for iron 3 ions mole per dm cube. Now use the formula. In this formula you can now put the values. Oxidized. Now which one is the oxidized form here? Iron 3 plus. Yes. So 0.5 will come in the numerator and 2 will be in the reduced form. Why is it not 1 in this case? But as we used in the previous case, we are not considering it as 1. It's aqueous and it's the ionic form. It's not the metallic form, the atomic form. So that's why we are going to use its value as well. Now, how much electrons are involved in this reaction? How many electrons are transferred in this reaction? Because we are basically using we have to find the value of Z as well. 1. Exactly. So 1. Only 1 electron is involved. So the value of Z becomes 1. So after substituting the values, you get the answer. It is 0. It is 0.734 volt. Now take another example. Now this time we have some additional information as well. In an electrochemical cell containing copper 2 ions to copper and iron 2 ions to iron, calculate the electrode potential of the cell. If the concentration of copper 2 ions is 2 mole per dm cube and the concentration of iron 3 ions is 0.005 mole per dm cube. Now here you have two different elements with their two different states. We have copper 2 plus 2 copper element and iron 2 plus 2 iron element. And we are supposed to find the electrode potential of the cell. So this time the cell is made up of two half cells, the iron and the copper. So how would you find that value? Can you directly use this formula? If you want to find the electrode potential of the reaction, it means you need to find the value of this E, right? You are, yes, we trace back this reaction. We trace back the whole numerical. We have to find the value of E. For this purpose, you should have the value of Z, oxidized species, reduced species, as well as the value of E naught. Do we have the value of E naught? No. We are first supposed to find the value of E naught. And how do we determine that? If we have two different elements, then how do we determine the electrode potential of that type of reaction? No, that is for the Avogadro's constant. We use the electrode potential value of the cell. Electrode potential value of the cell. And we do remember those formulas of the calculation of E naught cell. What's that formula? Electrode of cathode minus, yes, cathode minus anode. E of cathode minus E naught of the anode. Now you have to determine the cathode and anode from here. How would you determine that which of these two is the cathode and which of these two is the anode? You have to you, you have two different elements. You have two different elements which are connected or joined to make a single electrochemical cell. So which values do we take the help of to find the cathode and anode? Exactly. We take use of the electropotential values. So in the electropotential values, you will see that the value of iron 2 plus ion is given in the electrochemical series. It was somewhere here. Anyways, leave it. The electropotential value is given 0.44 minus 0.44 volt. The same value is taken from the data section. And for the copper, it's plus 0.34. Now, which of these become the cathode? Exactly. It will be cathode, and this one become anode. This is anode. This is cathode. Now use these formulas. Use these values to find the E naught of the cell. After using these values, you'll find it will become E cathode minus E anode. It is 0.78. Now you have determined the value of the E naught. This is the value of the E naught of the whole cell. Now put this value in this formula. In this formula, you have to find the oxidized species and the reduced species. So here, copper 2 ions is 2 mole per dm cube and iron 2 plus ion is the 0.05 mole. After having discussed that copper ion is basically the reduced, it is a reduced form. This will become the reduced form because reduction is carried out here, and this will become the oxidized form. So the value of the iron is 0.05. So in numerator, you will have 0.05. Why? I'm repeating. You have determined that this is the anode, which means over here oxidation occurs, and it means as a result of oxidation, you get the oxidized species. Is it so? Oxidized species, which means this oxidized species will come in the numerator, and the value for this iron is given in the question. It is 0.05 mole per dm cube, and that's the reason we have used this value of 0.05 in the numerator, and 2 mole per dm cube was given for the copper, which is happening at the cathode, which means the reduction reaction to over here. So after calculation, and one more thing, how many electrons are involved here? Exactly, because for anode, this reaction will be shown in the backward form, which means 2 electrons will be lost, and these 2 electrons will be gained in the cathode reaction, which means only 2 electrons are involved. Definitely, we have to make electron lost and gain to be equal. So that's why 2 is used here in the value of the Z. So that's the answer, 0.733 volt. Is it clear? All right. So that's all for today. We'll continue from here onwards in our next class.